Hello again, Tom from Every Step Calculus, everystepphysics.com. This, you can see the problem that we got here, which is the integral of x times sine of 2x squared, okay? Pretty deep problem, would not appear probably on a test because when you do it handwritten, which I do for every one of these programs, I have to write it out handwritten and find out the exact steps to do it in certain orders and make sure it's as easy as possible for you to pull it up on your calculator and do the problem. And it's 2 pages long, written pages, and these are college ruled papers, and every line is filled up with calculation. You notice that the reason that I say in my site that calculus never solved anything useful, never can solve anything useful, never has, it's because notice that these functions have to be, which look pretty simple here to this one, just a few characters, could have minus signs or whatever. All the information calculus can do in integration has to be in this function here. And of course, if you graph this function, they always turn out to be some sort of parabola. And of course, the integral is the area under a curve if you're dealing with the variable of x versus x, y, and z. And so, and there's no classes on creating functions. And in calculus they do have differential equations, first order, second order, but that's just reversing the process and doing integration, starting out with something simple, and then you have to know the plus c of every one of them and come up with some sort of equation. Anyways, let's do this one here, which is not on the internet. It was on the internet. They have x times sine of ax in problems, but I did it with the 2 here, 2x. And let's do it. Index 8 to get to my main menu, press enter. I'm already at integration by parts. I'm going to press enter again. And we're going to enter the function. We have to press alpha first, alpha x times left parentheses, second y is the sine function, 2 times x, right parentheses and then right parentheses, and then squared. And we press enter. See if we've entered it right. Looks pretty good to me. You can change it if you want, but I say it's okay. And we're going to do the problem. You'll notice that I is equal to the integration and equals the integral of x times sine of 2x squared with respect to x dx, okay? And we're going to use t substitution first. T equals 2x, which is this in the parentheses here, and use t substitution. Mostly in your, this will never be in a test because it's just too tough, but mostly in your knowledge of integration, you're going to be dealing with u substitution. Okay, well, this is the same thing, just using a different character because we have to do a couple of these in the problem solution. And so we're using 2x t is equal to 2x dt, which is the derivative of that, is equal to 2 dx. And then we move the 2 to the other side, as always. These 3 things here are the most important things I've found in u substitution or substitution at all. And you won't see this among many professors, but this is what's going on. And then of course we solve for x here in this, t equals 2x, and then for x is equal to t over 2. Alright, so let's substitute. I equals, here's t over 2 times sine of square root of t, and then dt divided by 2, which we found too, okay? And we do here's the division of 2, and constants always come out of the integral, so we have 1/4 outside the integral, and then the integration times t times sine of square root of t, dt, with respect to t. Well, here's an identity already. Sine squared of t is equal to 1/2 times the quantity 1 minus cosine of 2 times t. Okay, it's in the back of your calculus book. And then we have we do the calculations. Quarter times t times 1/2. Here's what we just found. We substitute that in. And we bring the, again, constants out. Turns out to be 1/8 over the integral of t times the quantity 1 minus cosine of 2t dt, and etc. So then we're, when we do the integration or the identity, let's see, what is this? Oh yeah, t minus t times the cosine of 2t dt. Oh, I see. We multiplied t times 1, get there, and then t times minus cosine. So here's t times cosine of 2t. All right, sorry. We expand the integrals. In other words, separate them. Anytime you have a plus sign or minus sign, you can make integrals out of the variables on each side of those signs. You have to use integration by parts. If you see a times, for instance, this one here, t times cosine of 2t, you need the integration by parts with that, or some sort of substitution. So we expand the integrals, come up with these two here. Now we're going to do the first integral. 1/8 times integral of t dt is equal to 1/8 of t squared divided by 2 is equal to t squared divided by 16 plus c. Second integral is this one. And we're going to use s substitution for this one. S equals 2t, ds equals 2 dt, ds divided by 2 equals dt, t equals s over 2. Same thing we did before, right, except a different variable now. And we substitute that into the equations, keeping track of all what we've done before. It's a great thing about programming, is that you don't have to learn this stuff. You just have to mark it down forever in your notebook, and in this case your calculator. Going to integration by parts. U equals s, du equals 1 ds, right? Integration of s is 1, and dv is equal to cosine of s. V is equal to integral of cosine of s, and is equal to sine of s plus c. We integrate, come up with minus cosine of s. Okay, we substitute that in. Here's a minus the cosine of s times 1, which is the derivative dt. And then we do calculations, bring out the constants, etc., right? Here's t squared, what we found before. And we separate, remember this is to the quantity, so you have to have 1 over 32 for this one too, cosine, so we do that here. We back substitute, s equals 2t, so now for s, so we find all the s's and make 2t, substitute for that. Here it is, 2t. Okay. And then we're doing again the bringing constants out and doing algebra and simple calculations if you can keep track of it, especially the minus signs here, etc. You can go slow and mark it down in your paper. You'll see that everything is exactly correct. Now we back substitute t equals 2x. We put 2x in here, etc., like this, and do all the calculations. I equals the mathematical determination and all this stuff here, and we come up with the answer here. X squared over 4 minus 8th times x times sine of 4x minus 132 times cosine of 4x plus c. Pretty neat. On everystepcalculus.com, go to my site, buy my programs, and pass your calculus. Okay, have a good one.